Welcome to Homework Lib.
To do the Fourier transform of the function f of x equal to 1 minus x in the interval from 0 to 1. And remember that whenever we have this kind of intervals, the coefficients for the Fourier series are going to be for a0, 1 over L. Well, first of all, this interval is going to be equivalent from 0 to L. So that means that the value for L would be equal to 1/2. So for the a0 coefficient, the definition is going to be 1 over L times the integral from 0 to L of the function of x dx. For an is going to be quite similar, but with the multiplication by the cosine of n pi x over L. And for the bn coefficient, kind of the same thing around, from 0 to 12 of f of x sine of n pi x over L, dx and dx. So we want to find each of the coefficients over here in order to get our series transformation. Recall that the series of f of x is going to be 1/2 of a0 plus the sum over n equal to 1 to infinity of an cosine of n pi x over L plus bn sine of n pi x over L. B sub index L sub index n. So the a0 coefficient is going to be equal to 1 over 1/2, which is 2, times the integral from 0 to 1 of 1 minus x dx. The result over here is directly equal to 1/2 times 2, so this is 1. Now for the an coefficients, we're going to be multiplying the function by the cosine function. So an is going to be equal to 2 times the integral from 0 to 1 of 1 minus x cosine. Since L is equal to 1/2, this is going to become 2 n pi x dx. And this integration will become sine squared of n pi divided by pi squared n squared. On the other hand, the bn contribution, the coefficient bn, will be 2 times the integration from 0 to 1 of 1 minus x sine of 2 n pi x dx, which is equal to n pi minus 1/2 of sine of 2 n pi divided by n squared pi squared. Notice that the sine of 2 n pi is always going to be equal to 0, because for n being an integer being from 1 to infinity, this is going to become 0. This is sine of 0 degrees, 360, 720, and so on. So the bn contribution is going to be, let me switch back to black, bn would be n pi divided by n squared pi squared, thus 1 over n pi. With this, we can write down our Fourier series from our initial definition. So f of x is equal to 1/2 of a0, so 1/2 of 1, 1/2, plus the sum of n equal to 1 to infinity of the an factors, sine squared of n pi, divided by n squared pi squared, times the cosine of 2n pi x, as we saw from this section. Recall that L is equal to 1/2, plus sine of 2n pi x divided by n times pi. And recall that over here, the sum is over both of the factors. So this is going to be the Fourier transformation of our 1 minus x function on the interval from 0 to 1.